Welcome back to the Decode podcast booth at IPC Apex 2025. We are here with Shantanu Joshi. Yeah?
Yes.
Can't look at that because we don't have it on the right page.
That's not me.
You work for Koki. Do you mind telling people what you guys provide and what you do there?
Definitely. First of all, thank you so much for having me. It's an honor to be here. This is your first year, so all the best wishes to you guys, and you're doing a great job. So basically, Koki is a Japanese solder manufacturer. We basically make solder paste, adhesives, fluxes, solder wire for both SMT and power electronics applications.
Okay, so how many different types of solder paste do you offer?
So if I have to guess, close to 350.
Wow.
Just SAC 305.
350?
Yes.
Wow.
You heard that right. So basically what our niche is that we will basically spec in a solder paste based on the requirements of a customer. And then the customer might come back to us and tell us that, hey, the slumping property is not up to the mark, or maybe you're having some, we need more tag time, we need more stencil life, and we can tweak the solder paste and make sure that it corresponds to your needs.
That's amazing.
So, like the specific properties that are affecting a customer, there's going to be this is what in your environment maybe you're struggling with. Well, then this is the paste for that application.
Right. So now we have so many different pastes that we can give you off-the-shelf products. But when we started with a leaded paste, and then once the lead-free evolution started, we did not cater to all the applications with couple of solder paste. So we basically used to give them the standard paste we have, and then based on the requirements and the challenges they had, we basically used to tweak the solder paste. That's why we have so many different parts numbers.
So somebody could go to you and say, I'm currently struggling with voiding or tombstoning or insert print defect here or reflow defect, and you'll say, we've got the paste for you.
Absolutely. That's absolutely right.
That's kind of amazing because, we were talking a little bit before. I have this one job that has this tiny IC on it. And I mean like minuscule. And I've been told, and this is a customer supplied part too, right? So I have no idea how old this IC actually is. So it could be the leads are contaminated or something, but it just floats.
Right.
It just floats. And then we have to usually like tap it down, tweezer, tap, solder, right?
Yep.
And they told us this would be a problem when we started this job. So this is like something, it's kind of cool because this could then rework that for me and reduce my rework time.
Right. So this is very normal, I think, because after COVID, because of the component shortages, you would see like out of the 100 parts, 98 parts are great. 1 or 2 parts you just don't have control over.
Yeah.
And then you might have missing plating. You might have ununiform, non-uniform plating, and you just are stuck with that component and you don't know what to do. So there are a lot of options that we can provide without changing the solder paste. So we can play with different aperture designs, different reflow profiles. You can have offset printing, you can have step stencil, or sometimes all you need is add a glob of flux and like a small tacky flux on top of the paste that you have printed, and it will just work fine. So we typically, what we do is we ask you to send us some components like in tape and reel, some virgin boards, and we will do an EDX to make sure that the plating thickness is actually good. Because if we don't understand that, then you are basically chasing a ghost. So you want to make sure that if the plating is good, then we can think about other options. If the plating is not helping you, then there is no other option but to add more paste or more flux to basically get rid of that oxidation.
Do you know what the reason is why the plating isn't good on?
It's just the supply demand. So basically, I think after COVID, I think because the lead times were like 52 weeks, 70 weeks, unreal lead times, I think the component manufacturers sometimes, I'm not saying they're bad, it's just that they might have missed something because there was so much pressure.
There's so much demand.
Yeah, the demand was so much that, and I'm not saying that all the lots you might get are bad. So out of the 10 lots, 9 lots are great. 1 lot, you might get 10 parts which are bad, but you are basically chasing a ghost because you feel like, hey, why only this part? Why not some other part? Why only on this side of the board?
That situation doesn't just happen with customer supplied parts. I've seen it also happen when a customer's design is old full of legacy component or obsolete, components that have gone obsolete. So they're not making them anymore.
Correct.
The quality as the overall quality of the parts that are available, as the numbers shrink, generally, like those few parts that are left, they're totally suspect. You don't know if they're still good or if it's obsolete. They might have been sitting in the back of a warehouse for years.
Yep. And then that's basically where the oxidation comes in. So some of the products that we have designed specifically for those applications are the powerful wetting solder paste, which can solder not only oxidized copper, oxidized nickel, oxidized tin without any nitrogen. So we basically had to develop a product specifically for applications like that, where they cannot change the everything, but they are okay using some other paste on areas or the components which are having issues on the oxidation.
And that has to be accomplished via the flux, right? I'm imagining it has a more aggressive flux in order to...
Right. But sometimes, for example, you might not have an ability to use water soluble because the components cannot be washed. So basically this paste that we developed is a no clean product, and the tag time is 72 hours. So meaning you can actually print the paste on Monday, wait until Thursday.
Oh, that's his dream.
Put the parts on, and then it will still reflow in air.
Can I hug you? Do you take hugs?
You don't understand. You're actually giving him permission to do what he kind of was.
So a reoccurring topic that we've had many times today is miniaturization, right?
Yes.
And since it's always fun to talk in extremes,
Yep.
talk to us about the smallest particle size or highest paste type number that you are working with currently.
Yeah, so we have a customer that does, I would say, like nano LEDs, if you want to call that. I don't think there is a commercial term for that part, but you can actually inhale the LEDs. Wow. So basically, it's
inhale the LED. They're that small.
Yeah, so you cannot see it by the naked eye. You need a microscope. But typically, when we go on the production line, we wear masks. And this is not for COVID, but this is because you might inhale the LEDs. So the parts are so small that there is no way you can rework it. And one of the issues that they were having is that the paste was not tacky enough. That the parts are so small that if you have less release from the stencil, you are basically dealing with so small parts that the amount of paste or the flux is not going to be enough for you to have that tackiness.
You need the paste to be acting like glue at that point.
So we basically changed some components, as I was telling you, and made the paste more tacky so that they don't have any issues when they are placing the parts on the board. The parts will adhere to the whatever amount of solder paste that they have. Sometimes it's maybe 4 solder balls because they are so small that it's a type 6 powder. So it's unbelievable.
Do you offer solder wire and bar solder also, or is
we don't do bar solder, but we'd absolutely do the flux core solder wire.
Okay.
And one of the projects that I was working on is for a laser soldering. I think a lot of people are trying to go that direction.
Yeah.
Not for all the board, but maybe for a couple of the components that might not be able to withstand like the longer reflow time for 3-4 minutes.
Yeah.
They can actually shoot the laser on it, basically do the soldering.
Selectively solder with a laser.
Exactly.
And
for in between like 1 and 2 minutes and done with it, so that they don't have to worry about like the optical components going through the reflow for 3 minutes. So
You acted like you've heard that before.
Yeah, I know multiple brands that do that.
There's laser solders?
Yes.
Yes.
Yeah.
That's amazing.
I'm not going to do a commercial for them, but I'll tell you when we're done recording. Yeah.
Wow, that's so crazy to me.
Yep.
I love it when you hear something that's so novel to you, because the excitement and the enthusiasm just
Well, now
oozes
he's got
from every
lasers at his
pore.
shop. I'm not going to buy that. I'm just going to use yours. Send it to you.
Might not work. It might go through the
It
board.
goes through the board, yeah.
Exactly. Yep.
That's amazing. I mean, I guess that's kind of like the future then, right? Like it just shoots all these lasers down on your board, boom, soldered, no reflow.
Not quite, but
So I think the issue with the laser soldering was it was basically designed to do 1 or 2 components. But then if you get to an application where you might have to do multiple components, then it's going to be a threshold for you,
a
because
throughput
it's
How would it do bottom terminated too?
Sorry?
How could it do? It can do bottom terminated, right?
It can. Absolutely, it can.
Yeah.
Yep. So
Yeah.
you are gonna basically point a laser on part of the pad, and the pad is gonna heat up. So,
Oh, okay. So
yeah.
just yeah.
Yeah, but a throughput is going to be a serious
Yes.
concern, right?
For
Because
now,
Yes,
now-
for now.
For
now you're
now-
talking about on a component level rather
Imagine
than
in 25
mass form
years
like
from
vapor
now.
phase
No, you might
or-
be right. You could have like a grid of lasers that would be selectively
Exactly.
programmed to
Yep.
location. Like I'm tracking with you.
25
Yeah.
years from now, the reflow oven, what, right? Like it's going to be, just get the lasers. Yeah.
Well, Shantanu, this was great. Honestly, thank you for joining us.
Thank you for having
hopefully
me.
the show's been good for
We
you.
would be remiss if we at least say Greg highly, highly recommended you. He talks about you so much too. I don't know if he tells you anything, but he's really inspired by your energy and passion for this, and clearly it rubs off, right? Because
Thank
I'm
you.
feeling it during the
Yeah,
interview
no.
too. So
He's a great guy, and
Yeah.
then we are happy to have him on the team. So
cool.
I'm
appreciate
happy
all
he's
your
out of
time.
the stencil industry.
Yeah. You and me both. So.
All right. Well, thank you.
Thank you.